John. Thank you, John, for inviting me here. I'm very, very excited to be here. Of course, some of you probably maybe remember I was here last year. So this year is very funny because this conference is right after CES. So last night I flew back, almost red eye. So if I look sleepy, you know why. So today's talk is actually different. When I was CES, we were focusing on virtual reality, VR. We actually talk about what's the future of VR, what does it take to make VR go into mainstream. So you can actually see our discussion, our panel discussion on this in our Facebook. But today's talk actually is focused on AR, augmented reality. We are a public company, so I was told I should show this. Okay. With that, I'm going to now start my talk. Today is going to be a very interesting talk because we're going to have a whole bunch of guest speakers, which I'm going to talk about today. The talk is, I'm going to go over the rules and guidelines for AR. And later on, we're going to talk about how we think the AR glasses should be designed. And then, of course, we'll make some discussions about it. Maybe a few years from now, we're going to revisit the rules and decide which emperors have managed to keep their clothes on. So we're going to talk about, Kopin is actually a 30 years history. I have believed in AR, VR for many, many years. And so many years when there were no such terms as AR, VR. And so we're going to talk about a little bit about the history. We started actually with DARPA, as John mentioned, early 1990s, to put wearable computer on mobile soldiers. And they gave us quite a lot of money, but it actually took us 30 years to get here. We presented these rules last year, the 5 basic rules to get AR. But later on, we actually were going to a bunch of guidelines, how to design the glass, okay, how to design glass. But in between, we have a lot of good special guests. We have Bose, we have Google, Z-Space, and PTC. These are very important examples. They are the ones that have done it right. I go back to the history again. I think Confucius is important. They always say you have to study the past before you can define the future. So today, we're going to start on the past. What happened? What has happened? What has failed? What has succeeded? And why did they succeed? First of all, I think that last year has been a very tough year for VR and AR both. I think we have been heading in too many directions, too many mistakes. And I think there's a clear path is actually evolving now. And I'm going to go over what has succeeded and what will succeed in the next 3 years. Back to the history. It started in 1990s. DARPA came in and they say, we want a computer on your head, mobile soldiers. At that time, the screen was CRTs. We were horrified. We proposed that we should do micro display. And that's where DARPA did. They actually funded us $50 million, $10 million a year for 5 years to develop solid-state micro displays. And out of that, a lot of products have come out. As you well know, IBM actually put out the first wearable computer with us, and that was in the mid-1995 time frame. But we always throw around, we have cameras, viewfinders. The viewfinder is very interesting. It's actually a video see-through to take over optical see-through. Okay, and then we have now, of course, have products like Go-Down Infinity, Google Glass, and then, of course, Solos. Some of this you can see outside today, and I think there were talks going to talk about that too also. With that, let me expand. I think the display components, we provide display components to military, to enterprise, and now, of course, the consumers. So our market share is pretty big. So we actually may be the right one to talk about what has succeeded, what has not succeeded, because we are providing the bullets to everybody. But first one to talk about is this one. Okay, a lot of people don't understand it. We're the sole source of the optical modules displays to F-35. F-35 is the most advanced helmet in the world. Of course, F-35, you know, is the fighter jet, the most advanced fighter jet. This helmet sells about $500,000 each, okay? And it's a very interesting helmet. If you look at it, it's actually all camera-based. It has cameras all around, so people can see almost 360 degrees in the daytime as well as at night. Okay, the cameras give the images to the pilots. In addition, it has a lot of voice, so the vision as well as the voice give them the situation awareness. So the pilot is willing to wear these incredibly heavy things on their head, it saves lives, and in a very confined space. Okay, be honest with you, he would take it right off when you landed. It is very heavy. But it is the most advanced display system. It's an AR/VR system. You can see in the dark, see everything around. How about the other one? It's also very useful. The AR is again for enterprise work. Is this a fireman thing? This is one of the most bulky, ugly things they can wear. But fireman wears it. With a little thermal vision screen that we provide to them, they can see, go in there, they can see where the fire is. Okay, it saves life again. People will wear it. But of course, he will not wear at dinner time. So let's talk about what's going on in AR/VR. There's a lot of discussion about AR/VR. Today, I'm going to concentrate on this part, the AR. Because people talk about VR, virtual reality, which is really a digital world, and it's AMR. There's a lot of these definitions, XR, and now people, I think, get very confused. The consumer especially got confused. But AR is very interesting because I think this is where mobile world is all about. Okay. So military, I won't go too much about what's the status today. I think the military is using it, enterprise using it, consumers rejecting it, and now we say why. Okay. First of all, why people want it? Well, AI is actually an augmented digital world. It allows you to get a heads up. It's a horizon. You can see in the horizon. You don't have to bend down now. It can be hands-free. Now, of course, people put it on the watch, put it on the head, on the body, but we believe eventually it should be all on the head. The human senses are around the head, so the best is going to be on the head. With that, I would say, okay, you want to make a mobile AR glasses. What are the basic rules? Remember, we're based on this 30 years old. In the early 90s, IBM built the first wearable computer with us. And all these years we learned. The first thing we learned is the human actually comes first. Technology comes second. And that's hard for people to swallow, especially at MIT. MIT, of course, technology comes first, right? No, the human comes first. Okay, next one. The most important thing is humans really do not like to wear things on their head. It's very, very hard to believe that, but you all have their glasses, wear their hats. Let me show you some of the examples. These are the situations people wear, right? People wear sunglasses, of course. People actually wear these earphones, or this earphone, or of course, yesterday we saw this. And then safety glass and the F-35 helmets, and the glasses like this. Why do they wear them? Because they provide benefits such that they will wear them. They can either augment their vision, augment their ear, the voice, okay, of the voice here, or vision here. So a lot of things are augmented. All these are, in fact, AR glasses. They may not be smart AR glasses, but they are AR glasses. Okay. So the second rule is we have to make sure the physical world does not overwhelm our artificial digital world. I mean, you probably saw this before. This is terrible. Your human brain cannot absorb it. Extremely dangerous. I don't know why people even propose to do that. Okay? So your visual world cannot overwhelm your physical world. And that is another thing that we hear. People, again, putting too many features into the eyeglasses. They should strip it down, strip it down. But third rule is situational awareness. A lot of things, especially VR is especially bad in the sense you get your totally enclosed. Humans need some physical space, awareness space. So this is the thing. The two things are very important. Like these are the 5 senses. The sight and sound are very important physical senses. Especially sound. I think people have underplayed the sound. Sound is actually give you a two-way communication. Okay, vision actually cannot. Vision give you the physical awareness. The sound is especially good for two-way communications and with physical awareness. All the other senses are not as important. So your AR glasses had to focus on these two. In fact, I think every AR glasses should have voice. Should be voice control, voice centric. And then you can think about vision, which gives you the physical awareness. And later on, I'm sure both John will agree with me on that. So now go back to the voice. We think voice is the next touch. The touch screen is beautiful for cell phones. The cell phone is wonderful. It enables the smartphones. But when you go to the wearable, in addition to display and other stuff you need, actually voice is the most important one. It's the next touch. It's the next user interface. Without the voice, you really don't have good glasses. Now the question happens, well, why voice is important? Voice is very important. You have speakers, technology is already here. It's really the input to the voice. You go to the voice, things are not repeatable, people don't understand it, it's a too noisy environment. All these are voice things they have to solve. So both voices are actually much better communication interface. It's a user interface. The final rule is we got to have design that's purpose-built with the benefits. If you don't have the benefits in mind, and in fact, build the eyeglasses with the benefits in mind, otherwise, you try to jam everything in there, try to pick a Swiss knife, and it's going to fail. So I think that so with that, I'm going to show you some of the examples that people have done it right. So first of course, we have John going to talk about the Bose frame, which is all voice-centric. This is the importance of voice. Google Glass, we have Jay here. It is actually very well-designed purpose. It's a very designed purpose for the enterprise. We will have Jay talk about that. And then we're actually going to talk about Z-Space. Z-Space will come in. We'll talk about a very simple way and how to the benefits. It's very, very, very good for simplicity as well as PDC on software simplicity. This is very well designed too. So with that, I will actually get John to come in to talk about the first John. So let's welcome John from the.
Great morning, everybody. Thanks for having us here with you. So I'm excited to talk a little bit about Bose in the AR space and how we think about sound. Now, how many people generally think of Bose as an AR company as you've looked around, right? Probably not too terribly many. But I would suggest if you take the most broad reach of what AR could mean, from Dr. Fan's presentation, taking the digital information, mixing it with the physical world, that goes all the way back to what many of us have done at Bose for over 50 years, and that's about music. And so if you start thinking about music, how many of you can think of a song somewhere, when you hear it, it takes you back to some point, right? It takes you to a spring break somewhere, it takes you to, it's your wedding, it takes you to, someplace you've been. How many of you have something? Some song, when you hear it, it takes, we all do, right? And that's because we were in the physical world in reality, but that song or that music puts you just a little bit over the edge of making it more real and more deep. I can actually tell you the first time I got my driver's license, 16 years old, I come home, I get into my 1983 used Chevy Camaro, great vehicle, right? Turn on the car, and the song that was playing was Tom Cochran's Life is a Highway. Anybody know the song? You might know the Cars version from Rascal Flatts, right, that your kids would know. But that was the original, and when you just get your driver's license and you're in a car and you hear that, you feel like the universe is speaking to you about what reality is. So when we start thinking about how could we use just sound, but actually make it more deliberate to understand what you're doing and give you audio cues to push that forward. So when we came out with what we call our AR glasses. The first product we had is called Bose Frames that just came out right before the holidays. We really wanted to take Dr. Fan's rules and say, start with what the customer's benefit is. So I'm going to show you a quick video of how we show this to customers, and you won't see almost anything about AR in here, right? So watch for just one sec.
Cause it's sunshine dripping down my face.
Okay, seem interesting? So these are Bose frames. If you pick them up, they feel just like any other pair of sunglasses. The glasses are just sunglasses. Right? There's nothing else on the screen. Nothing else pops up in front of you. The weight, the feel, everything about them is exactly the same. In fact, except for this like tiny little gold button here, you could think that they were just regular sunglasses that people were putting on. What we wanted to do was start off with what Dr. Fan said, find something that people want. People want to bring music into their lives. They want to bring sound in, and they will put something on their head to do it. But we wanted to go beyond that. We wanted to figure out, now that we've got something on people's heads, how do we help them get their heads out of their smartphones to look back up at the world and engage with it in a different way? So you can see this person here is looking up, not looking down. How do you stay heads up and hands free, but stay engaged with what's possible? So we put in these that you didn't see in that discussion. We've talked about our Bose AR technology platform. That's not just going to go in glasses. It's actually going to go in everything Bose makes that's new that goes on people's heads. Headphones, earphones, everything else is going to have the same technology in it. And what it does is we put a whole bunch of head tracking sensors in as well as microphones. So you might think of magnetometers or accelerometers or gyroscopes all in the device. And what that helps us do is we actually get context around how you're moving. So not only do you play sound like music, like that song I was talking about at the beginning, you don't only have that happen serendipitously, but you bring in the right type of audio content because you know what someone is doing and how they're moving. So I've just talked about that. That sounded a little bit wonky to me, right? Using all these sensors and moving that forward into an SDK. So let's take some examples around how this could work. So have you ever been to a new city and you're walking through a city and you look up and you see a really interesting building and you're like, I wonder what that is, right? And you pull out your phone and you go look at it and you look for what the TripAdvisor or Yelp or something else says. And you're looking down at it, you look up and you look down and you're trying to match and figure out if you're in the right place. Well, when you have something on your head that knows what your looking direction is, right? Because the magnetometers and compasses know where you're going, and the GPS on your phone knows where you are, you can walk down a street, and if you look at something that's interesting, and you can tap the side of the glasses, and without changing your gaze at all, it will tell you what you're looking at, right? You have the ability to stay entirely present in the physical world and walk through it, and just hit it and have something talk to you about what it is you're seeing. It's like having an expert tour guide with you as you move through. So that capability is unlocked because of the fact that we know where you are and we know where your head is looking. So you have that ability. If you want to hear more about it or less about it, you could nod or shake your head or tap again, or any of those gestures, interactions now keep you present. So this started with us as we started talking to some creators about how they would use this. We expected TripAdvisor would take its content and skinny it down so when you looked at something, it would kind of read you the basic version of it. But what we started to realize was there's this whole world of audio content that you could pin to the real world. So think, what's the architectural tour of this city? What's the blues tour? What's the tour of a famous person who's gone through here? There can be layers and layers and layers tied to the same physical space. And our goal is to keep your eyes present in the physical space, but add in the right layers of digital just in audio so you stay present. And we think this is going to be something that helps people track the adoption curve and really get consumers excited because they'll get into the platform for the fact that they want to hear music, but it will give them the opportunity to turn on a different type of audio. So let me flip a different example. Fitness. If you've ever worked out with an app that does fitness before. I was in Austin, Texas at South by Southwest, and I was doing one of these app-based workouts. It said run, then it said go down and do a plank for some amount of time. It probably said do like a 2-minute plank. I probably did about a 45-second plank and said, forget it, I'm out. I want to find a taco stand somewhere else. So, but the app kept talking to me as if I were continuing to do a plank, right? I've now sat up. It says, you're almost there. Keep going. 1 minute to go. And I'm, sort of laughing at it, right? But you know why I didn't know? Because when I'm running with a workout, when I'm like down doing something like that, I set my cell phone down, right? I set my smartphone down. It doesn't know what I'm doing. If it were attached to my head, as soon as I got up from that plank, it knew exactly that I got up, right? It knows if you're doing push-ups, how fast are you moving? If you're doing sit-ups, are you moving in or out? So the ability to personalize workouts, maybe not just when you're wearing sunglasses, right? Maybe when you're wearing sports earbuds. Anybody wear any kind of headphones when they work out, earbuds or anything, right? Music and sound. So again, you go back to giving people something they're going to buy anyway. They're going to buy earbuds for sound, to be able to have those situations. Why not put the sensors into them in the same space so that now we can unlock a level of augmented reality that you can't do without them? So that's the second example, but different from the location-based one. So the third one that I thought got interesting was gaming. And so we didn't know where this was going to go, and people started suggesting maybe because there's sensors on your head, you can have a video game on your phone and you can control it with your head. That turns out to be a horrible experience. Don't do that, right? So what the teams that we've been working with started is they said, we can make real immersive games in the cities that you're in. Imagine you've got an audio game on, so you're walking somewhere. You're walking to Kendall Square. You're walking through Kendall Square, and the game comes on and says, don't turn around. There's someone right behind you. Now, you actually know, because it's on your head, if the person turns around or not, right? And you change the game based on how you're interacting, right? There's someone following you. Duck down and pretend like you're tying your shoes real quick, right? You know that the person did that. Now you're out in the middle of the street with people all around you, and you're interacting as if you're in the middle of a movie somewhere, right? And it starts to make the world much more immersive. So you're augmenting that reality while keeping the person 90% in reality. Because we know how you move and how things go forward, you can change the type of interaction model. So this is what we're thinking about when we think of audio augmented reality, still on your head, still playing audio streams, not just music, but using it to actually make you more immersed in the real world. And when Dr. Fan started, I wasn't sure if he was going to say we were one of the people with clothes or we were going to be the example of the ones without it because we forgot to put any visuals in front of it. But because of the simplicity of this, and because Bose provides to customers millions of things that people put on their heads already, we're going to put the technology in all of it. And so we're positive we're going to have over 1 million devices before the end of this calendar year in customers' hands that they will have this technology from, because they're going to buy it to listen to music, people first, and then they're going to be able to apply it to drive these kinds of solutions. So we're excited about where this goes. We're excited about making this open now to developers at developer.bose.com. We've got a $50 million fund and are looking to highlight companies and creators that are working in this space. So very exciting. I hope this has maybe opened up your eyes to a different area of augmented reality, and look forward to seeing what you can do with that with us. With that, I'm going to hand it over to Jake Athari from Google. Thank you.
Jim, of course, is the head of Google Glass, so he's the right person to talk about Google Glass.
Hi, everyone. Thanks, Dr. Fan, for inviting me to participate today. My name is Jake Athari, and I lead the Google Glass program. I just want to give a little bit of context, and I think what we've heard so far about understanding what people need and what people want and what people are willing to engage with and putting the human first is really, really critical. And that's part of what, when we launched the Glass program in 2012, was the intent. We launched a piece of hardware that had all the sensors that you could have ever imagine that you'd want in a heads-up display product and a information display. And then we were the first product to have a fully voice-controlled environment. And then we took it to the explorers that we called, the people that we called explorers. And those are the people who were going to help us figure out what this device was useful for. So that was one big learning for us, was how do we use this device? We talked to academics, we talked to athletes, we talked to professionals, and we talked to people in the enterprise. And so my shift in this product happened around 2015, where we started to focus on enterprise. And a lot of the work that was actually done here with people like Thad and Rich turned out to be something that the enterprise market knew exactly what a heads-up display product like glass would be useful for. It took us a little time to figure it out. So in 2015, we sort of caught up with that, and we made a lot of partnerships with customers who actually had been using this technology for a very, very long time. And then last year, actually 2 years now, we released what we called the enterprise edition of the product. So what I wanted to share as actually taking Dr. Fan's rules in some way and seeing how we've actually applied those rules and how the market has sort of responded to us. And my first observation is that it really, really is important that people are interested in a desire to wear this product. Human first. Going back to Dr. Fan's first principle, human first. It's not valuable unless somebody's going to wear it all day long. The other principle that we thought of was easy to develop for. When glass first launched, and a lot of the AR products that we have today are really, really difficult to develop for. Glass, we had new types of SDKs, new type of development paradigms, new type of interaction paradigms. And then the last one is easy to deploy. So when things go out of an innovation lab, when things go out of development, they actually have to be implemented in the real world. So you have to think of things like MDM. I'm going to give you a couple examples here. So first, easy to use. We actually had a customer who does manufacturing and logistics. I'm not going to name the customer, but they came to us after about 6 months of use of the first generation of glass and said, this is amazing. Their executives came back, I should say, this is amazing. We're getting 30% improvement in productivity. Safety is improved. We're no longer getting people calling in injuries on the job because they managed certain boxes and they did certain things that actually caused strain on their employees. Because for some reason, all the employees who are using your heads-up display product glass, they're getting colds and sore throats. Can anybody guess why people who are using glass were getting sore throats? No, wasn't that, but that's a good one. They disinfect it after every use. Anybody else? That's actually really close. Their mouth was always open. It wasn't because they were impressed, though they were. It was actually because the UI that they had designed was very, very much aligned with the pick-by-voice tool that they had had. They weren't taking advantage of certain features that they could have. So people were doing multiple confirmations. They were saying, OK, next step. OK, I'm ready. OK, confirm. Instead of doing pick by voice and tapping on a button here for next step because they had a little control block, they were actually just saying the command over and over and over and over again. So people were actually getting sore throats by using it. Small design change in the UX changed the experience completely. My favorite example that I use when talking to people who have never experienced glass is the idea of putting together IKEA furniture. We all have a friend who has an IKEA bookshelf where the shelf, the unlaminated side is showing because they got so frustrated that they didn't want to go and disassemble and put it back together, right? Actually, this was a major part of the problem that these manufacturing companies actually see, that they do step by step, and often something gets so complex that they can't go and undo what they were doing. And so with glass, they were actually able to inspect the work along the way and turn it around and go back for it. But that was very, very difficult to develop for. They actually had to build their own computer vision kind of capabilities to assess what people had done. We went back and said, you guys, you don't need to build a large computer vision tool. Build the tool that's right for the job. So they started to build, using standard Android SDKs, ways to go and take pictures and confirm the steps that people were doing and get a manager to approve. And the last one is easy to deploy. This is something that has taken, I think, the overall AR industry, when they go to production, a little while to realize that you need things like MDM, IT, you need HR on board. You need people in compliance to actually buy off on this and say, this is how you should use it. You need people to actually make sure that they sanitize the product after different shifts. So these are the kinds of things that we've observed that are very, very human-centric, even though they are in terms of a technology product. The other aspect is that we keep on talking about AR as a holy grail, and I probably am not the right person to be saying this, but I'm going to say it, that smart glasses are not the solution to everything. And often we see customers actually come and say, I want the glass, I want this, I want that, and it's going to do everything. Very, very quickly, we learn that they're going to fail. One of the things that we've actually learned is that you need to use actually multiple wearables along with an information display product. So we have customers like DHL who work in logistics, and this is a very easy example to understand, is that if you are doing logistics and you're doing picking in a warehouse, you often have something on a high shelf or a low shelf. If you're wearing a pair of smart glasses and you want to take the item on the low shelf and scan it, what are your options? One, bend down, pick it up, look at it, not it, put it down, or get down on the ground, tilt your head, look kind of funny, or start doing jumping jacks to get to the top shelf. But what we actually recommend is customers pair it with another wearable. They use a ring scanner, they go like that, and they can go like that. It's very, very straightforward, very, very simple for them to do. And this is the punchline that I want to get to, actually, is that we often talk about how can a product like glass or other wearables give you superpowers? And this is, in my mind, the best way to give somebody superpowers. There are two macro trends that are affecting blue-collar workers and white-collar workers today in the United States. 10,000 people retire. I think it's every week, and the average tenure of somebody in a role is measured in single-digit years and no longer in decades. So institutional knowledge leaves companies really, really, really quickly. And disseminating knowledge is very difficult. So what some of our customers are doing is that the more senior staff are putting glass on and recording the steps that they do, the standard operating procedures that they do, in order to document the best practices. They do it with their senior staff when they have institutional knowledge that's retiring. The other way that they do is they find their best performers, put glass on them, and record step by step. And it's actually really straightforward. In MRO for maintenance and repair, one company that we have as a customer, what they do is they put glass on, they have a new product that shows in a new vehicle. The person will say, OK, I'm opening the oil pan, it's 3/4 turned to the right, and they'll actually record it, and they'll keep on saying step by step by step. So in real time, the new standard operating procedure is created. Then other staff who are new and who are training will actually go and use that standard operating procedure and all have the best practice in play. We have another customer who's actually done something that's really interesting. They're an auto manufacturer in the US. They have a standard operating procedure which every employee wears, glass, and it's delivered through that mechanism. And they're supposed to follow it. And between each step, they take pictures, and they're told to validate that they've done the steps right. They use this to actually ensure quality control of their product and ensure quality control of their processes. One really, really interesting thing happened with this particular auto manufacturer. During the paint cycle, what ended up happening was the car panels would come down a sliding lane, and then they would paint them, and they would put them to dry, then they would paint the other side, and then attach them to the vehicle. This one employee figured out that if you paint the inside, the outside, let it dry, paint the inside, and then attach it right away, you get higher turnaround in car vehicles. Immediately, what first thought that we had was, oh, well, you're putting wet paint on the inside of the car. He goes, actually, you're not. There's spacers in there, so you're good to go. You just have to be really careful. He actually violated standard operating procedure, and he was going to get sent to be retrained. Turns out, when they looked at all the data of what he had done and his inspection logs, he was actually doing things about 25% faster by doing things not the right way. And so he actually invented the new standard operating procedure, and it got turned around so that the entire company had that ability. So it's a really cool, full continuous improvement process that kind of happens as a result of using the wearables in the right way. So one of the big things that we've talked about, and I've alluded to in here, is that we're going to focus heavily on using computer vision and machine learning. Whether it's to make a pizza, we have customers who are using glass in training for making a pizza. About 50% of staff in fast food have turnover in about 6 months. So you lose about half of your staff every 6 months. And so training in fast food is really, really important. So one of our pizza companies, they actually use glass to train. And instead of taking 1 week to train somebody, it takes a week. And all the work that they do in making pizzas during the training process actually becomes sellable revenue. They'll use glass, they'll do some computer vision and say, you've applied sauce in an uneven pattern, you've put cheese in an uneven pattern. You've not put the right amount of toppings in the right spots. It's supposed to be half pepperoni and half green pepper. It's not what you've done. So they can actually do real-time quality control inspections that way and reduce their training time from 5 days to 2 days. The other aspect that we're trying to do is make everything standardized. So standard Android, standard USB-C, nothing complex, nothing unique that doesn't take after standard things that developers already know. And then the last thing that we're doing is partnering with cloud services, whether it be any cloud service that you can imagine. The idea being that a lot of what we care about in this device is keeping it thin and light and comfortable, keeping it human-centric first. And in order to get the kinds of computational needs that we have to make these products compelling, you have to offload the compute. So we're putting a lot of effort behind new paradigms of computing in the cloud with the heads-up display product that we have. All right, that's it. Thank you.
Thank you very much, Jay. The next person,
I don't know who's next.
Next one, we're going to have the PTC people.
Thank you. Great. Good morning, everybody.
Mike.
I'm Mike Campbell. Nice to be here. I work for PTC, and we are focused on applying augmented reality and IoT and a whole bunch of other technology in industrial enterprise use cases. So the question that I'm here to answer is, what happens when you apply Dr. Fan's 5 rules in the industrial enterprise? What kind of value do you get out of them? So let me get right to that. What we've found by surveying literally thousands and thousands of prospects that have been engaged in our trial program is that there's a tremendous amount of value to be driven in the industrial enterprise in 3 areas. The first is manufacturing, the second is service, and the third is training, largely related to those first 2. So when we think about designing for an optimal AR experience, we're seeing a tremendous amount of value driven in these particular areas. Why is that? Well, if you're an industrial company today, there's some big challenges that are facing you, and actually you just heard about some of them. But skilled workers and worker turnover is a huge problem. There's a tremendous shortage of technical resources. People are doing work in more and more complex environments, manufacturing work cells, where products are serviced, and frankly, the products are becoming even more complex as well. And then finally, there's an increasing demand of immediacy that we are all driving. Most of you probably have an Amazon Prime account, right? You order something, you want it right away, and that's showing up, that's manifesting itself in all kinds of customer behavior. And what we found is that augmented reality can help address a lot of these different challenges. It can help people be more efficient, it can help them be more effective, it can increase productivity, and it can increase customer satisfaction. And what I'd like to do is I'd like to show you some specific examples of where that is actually happening, of where manufacturers, or let's say industrial companies, are seeing the benefits of AR to do things like you see here. Improve their worker productivity, improve the effectiveness, the quality of the work that gets done, and improve the satisfaction of their customers because of this great technology. So let me start. I'm going to give you a handful of examples. The first one is a company called AGCO. This is a large industrial company, makes agricultural equipment. And they had a challenge of training new workers to install different types of processing equipment. And what used to happen is the engineers would show up, brand new engineer out of college, let's say, would show up and be presented with a massive stack of paper documentation, hundreds of pages, literally, of PowerPoint slides. And what they did is they embraced augmented reality technology and began, first off, training their technicians using AR, and then also supporting the technicians when they're doing their installation procedures. And a couple of things happened. First off, they were able to reduce the training by about 60%, which is huge. But the second thing is an intangible benefit. Imagine that you're a 24-year-old college graduate showing up for your first job. You've grown up in a world where you've only known the internet. You've always had tablet devices. And the first thing that you get is a 200-page manual. Not very fulfilling, right? So this idea that these digital natives can work with this kind of great technology, even in industrial scenarios, is incredibly compelling and makes a big difference to the workers that are showing up there. The next example that I'd like to show is from a customer called BAE Systems. They're a global industrial company, but this particular site is about an hour north of here in Nashua, New Hampshire. And instead of me telling you their story, I'm going to let them tell their story. So let's go ahead and roll a video.
There's huge growth in this market, but it is unsustainable unless we embrace new technology.
BAE Systems is committed to solving the most complex problems our customers have.
Here at BAE Systems, we make the electric propulsion for hybrid drive buses.
Our production tempo has increased dramatically. We've brought on a lot of new people. That's forced us to look at innovative solutions to build product correctly every time.
How do we do that? How did we do that? Is with mixed reality.
When I first tried a HoloLens, I quickly understood that this technology would have significant implications for our business and that we needed to get out in front of it. We had to find a platform that could help us scale, and that's when we began the conversations with PTC.
PTC's mission is to bridge the physical and the digital worlds, whether it's manufacturing, operating, or servicing physical products. We came along and we had a mixed reality solution to allow them to create experiences for the HoloLens quicker and more efficiently. It's all drag and drop. You don't need a lot of technical expertise. You can get up and running right away. It just makes it a lot faster and easier to get a lot of people using the experiences that were created with our software.
PTC's mixed reality solution has allowed us to drag and drop our 3D models that we already have to create guided work instructions to deliver to our production floor in hours and at 1/10 of the cost.
We develop a step-by-step guide that lets the assembler completely assemble the battery.
You're not looking at this in 2 dimensions anymore on a screen that's far away from you. It's right in front of you.
HoloLens has really become beneficial in allowing us to train new people on this product 30 to 40% more efficiently.
Using the HoloLens, I was able to cut my assembly time in half. We can understand and we can learn so much faster, efficiently, feel a part of this process.
Microsoft has really nailed it with the HoloLens platform, and PTC is helping us scale this affordably across the enterprise.
20 years ago, we didn't have personal computers on every bench. 10 years ago, we didn't have 3D printers. Now I can't imagine building without those. And I think this is what the HoloLens represents. It's the next step in the evolution of high-tech manufacturing.
The future of mixed reality is really exciting because the possibilities are endless. We're just starting to scratch the surface of it.
It really is endless what we're going to be able to do and where we can go. This is going to help us get there.
Okay, so some pretty key things happen there. 50% reduction in cycle time and 30 to 40% reduction in training time, all at 1/10 of the cost of the next best alternative. So great example of value being driven in a manufacturing scenario. And then the last example really ties into some recent research that we've done with Aberdeen. And really you can read about the research on our website, but the key point here is that augmented reality is able to drive higher customer satisfaction and higher customer loyalty. So let me tell you about an example there. There's a PTC customer called Howden. Howden makes these giant industrial blowers. They're used in wastewater treatment. And essentially what Howden is doing is they're instrumenting these blowers using IoT technology with all kinds of sensors and analytics so that they can understand how they're performing. And they're able to maximize the uptime of these blowers by taking advantage of this information and presenting the information about the performance to the people that are buying them, the municipalities that are treating wastewater, for example. And what is happening is they are actually able to deliver. When they deliver one of these blowers, they're not only delivering the machine, but they're also delivering an augmented reality experience and the digital eyewear that goes with it so that the operator can understand operational efficiency, but also perform the service on their own. So it's a great example of helping the customer, the end customer, take advantage of AR by packaging everything up so that they can get better productivity out of their products. This is one other example of the value that AR can drive, and this ties back to some of the things that we heard about this morning, which is sort of this collaboration idea, right? Here we're looking at technology that allows somebody that's a technician in the field to collaborate with a remote expert, to each of them, to the expert to see what the technician can see, and then be able to mark up using AR their view of the world. So it's a great way to communicate. It's a great way to clearly, without any ambiguity, instruct people on how to get something done. Maybe when you don't have pre-authored instructions or you don't have a good manual. So this is also great new technology that's available, and again, driving a lot of value in the enterprise. And everything that I've told you about here is all available today. This isn't futuristic technology. These are metrics that are available today, technology that's available today. It's available on the HoloLenses you saw. It's available on monocular eyewear, like the Google Glass device that you saw as well. And there's lots more coming. There's a ton of work that we're doing at PTC to do more of this kind of thing. You heard from Valentin about some of the research that we're doing. You've also heard that we're moving to the seaport and we're hiring. So if you're interested in helping us in this journey, please reach out to us and let us know. With that, thank you very much.
Our last speaker is Michael Hubbard.
Yes, right here. All
He's
right.
going to talk about for education.
Absolutely. Well, thanks to Dr. Fan and Kopin for inviting us to be here, because we're a little different than the last three companies. Probably first and notably is how many people have heard of zSpace before this slide, and Dr. Fan introduced us. A few more than I thought, but certainly not as many that understood Google and Bose and PTC. So what I thought I'd do, and you're not alone, by the way, as Charlie Fink, who's going to be speaking later today, wrote, we're one of those big unknown companies in the general augmented reality space. So I'm hoping, if nothing else today, to educate you about us, but more importantly, how we align to really the 5 rules that Dr. Fan outlined, because we've lived those rules now for a period of time. But let me start and just, we've been making quite a bit of news in an industry which is in education. So I thought I'd start and let them speak and show you a quick video of how we're being seen using augmented reality in education.
Reading, writing, and virtual reality is a different type of school bus.
The zSpace virtual reality bus visits schools across the country.
It shows students and teachers how schools across the country are incorporating virtual reality into their lesson plans.
Students and staff visiting the virtual reality school bus used all-in-one computers and got the chance to see the world's first AR/VR laptop.
From the outside, it might look like a typical bus, but on the inside, it's a lab where students can dissect organs, operate robotic arms, catch butterflies, and even build homes.
Now, it's all in a virtual environment, so it rules out the danger, difficulty, or mess that such an experience might bring in the real world.
zSpace is a VR, AR, virtual reality, augmented reality combination using these glasses and this pen and a 3-dimensional screen.
With a pair of these glasses and this pen, the virtual...
Uh-oh.
Reading, writing, and virtual reality is a different type of school bus.
The zSpace virtual reality bus visits schools across the country.
It shows students and teachers how schools across the country are incorporating virtual reality into their lesson plans.
Students and staff visiting the virtual reality school bus used all-in-one computers and got the chance to see the world's first AR/VR laptop.
From the outside, it might look like a typical bus, but on the inside, it's a lab where students can dissect organs, operate robotic arms, catch butterflies, and even build homes.
Now, it's all in a virtual environment, so it rules out the danger, difficulty, or mess that such an experience might bring in the real world.
zSpace is a VR, AR, virtual reality, augmented reality combination using these glasses and this pen and a 3-dimensional screen.
With a pair of these glasses and this pen, the virtual...
All right, so that gave you at least a flavor, hopefully, of the technology. It's a little bit different. We do the augmentation on the screen, on the computer screen itself, using glasses. It's a very simple technique. And yet we didn't start in classrooms. We actually started, not unlike Kopin, with the federal government behind us. So we were initially focused and were found by the U.S. Intelligence Service. And they had some key requirements, and I think these align, and this was almost 12 years ago when we started this venture. Very much the rules that Dr. Fan has just described. They wanted something comfortable for daily long-term use, something that was collaborative, not isolating, intuitive. And the last one is almost most important from our viewpoint, which is an integrated experience. It didn't require me to do something different. I was using my technology as I use it before, and I just want to augment it and enhance it. I don't want to change it. And so that was a key requirement. Since then, we've now expanded and moved our presence into education, as you just saw in that video, as well as in hospitals, because they had a very similar request, which was, we want the benefits of augmented reality. We want all of that potential. We want to engage our students. We want to learn better how to do surgeries. We want to understand things in a deeper way. But we want to do it in a way that's human-centric. We don't want to put things on and be in an uncomfortable place. And for certainly students, we don't want them to be someplace else. We want them to be with us and learning collaboratively. So we've been delivering to millions of students over the last several years. But I want to talk for a minute about the technology itself and how really we've evolved that, and those 5 rules have borne out as we've done it. Because we've gone from display attached systems all the way to our latest laptop, which is just starting to ship in the market. And in all of those, they were built to be human-centric. We all use screens every day. We all pick up a laptop. We all work with a computer, and yet we do so in a constrained way. We're flat. So with zSpace now, you can do that work in Google Docs or in various tools and office productivity tools, but when the value exists, then you bring out that augmented reality experience. We do that with eyewear that people want to wear. They're just glasses, but they do provide head tracking. They provide that immersive experience, but they do it in a way that makes them feel very comfortable in doing so and allows them to see their partner next to them and collaborate. And lastly, we bring in those other sentences. We use sound. We agree that's very important. In schools, they do it with headphones. And we bring in haptics. And we did that with a stylus. Now, why a stylus? It's because every kid in the country knows how to pick up a stylus or a pen or a pencil and use it. And we did that introducing haptics and very, very common, simple interfaces. The last comment is you'll notice there's a wire on the stylus. That's human-centric. Our customer didn't want a battery. They don't want to charge. So although we could certainly do wireless, they said, look, we want a wire on this thing. We're going to go old school because we want that to be attached to the device. So beyond that technology is a solution. We all know augmented reality, certainly zSpace, is not going to succeed unless we have a complete package for that end user experience. And we do that and had to do that for our education customers, spanning applications, creating a third-party ecosystem which continues to grow to deliver educational applications. Content, meaning it has to be aligned to standards and lessons. And as the prior speaker said, you have to install it. You have to think about how they're going to actually use it and work with those IT organizations and across school districts in our use case to make sure teachers get professional development. They know how to use that tool to its maximum effectiveness to engage their students. And because of this, we've had studies now at the university level that have demonstrated well over 16 to 20% absolute grade performance improvement using zSpace in the US and in China. You have to have flexibility for deployment. When we listened to our customers, they said, look, we have some school environments where we want to put them in one place, and then we have other school environments where they need to go mobile. They need to be within the classroom. So we've introduced both the mobile classroom model as well as the lab model, all through listening to how that customer wants to engage with that augmented experience and where is the best place to do that. And what we're working with Google on right now is to bring that to the web interface as well. Because in schools, you have Chromebooks, there's a lot of web content, and there's no reason at all, and through the standards work and the web VR work we've been doing with the Google Chrome browser team, we're starting to deliver that same magical experience now via the browser on just pure browser-based interactions. So although most of it today is in applications, Unity-based, Unreal, we're starting to see that quick migration towards doing it over standard-based web VR delivery. Where are we going now? What are we thinking about as a use case? Well, I would say we're being dragged into the home. We didn't start this as a consumer-oriented device and product, but what we're finding is in our education market, virtual or homeschooling is just this blended learning trend is huge. So what we're faced with now is we have thousands of students who have a zSpace in their house. And what are they asking for? They're saying, well, this is great to learn science and technology, engineering and math, STEM. It's helping me, and the parents say it's helping their students be more successful. but they want to use it more of the day. They want to have entertainment experiences. They want to have the advantages that zSpace obviously gives to them in learning. They want to see that extended into those other areas. So when we look at our future and what we're thinking about as we think about design, think about interaction and new content, it's around how to bring the right content into the home. It's not all content, it has a place, but the right content into the home. But with all this talk today about technology solutions, I think one thing I would leave you with, and Dr. Fan described it as human-centric. In our world, it's student-centric. And everything we do at the end of the day doesn't really matter how good the technology is, how compelling it is, and even how good the solution is if it isn't having an impact on these students' lives. And I can share with you, last week I was at Buffalo Public Schools, one of our largest school districts. One of the poorest, actually I think they stated they're the poorest the poorest city in the country right now, over a 40% poverty rate. They've deployed zSpace across their entire public school system. And what they're seeing is hope. They're seeing belief brought back to their students, and they're seeing real change. And to me, that's why we're all here, and that's the power of augmented reality. So thank you very much. Thank you. There you go.
We should thank all the guest speakers. I would like summarize and put everything in context in the next two view graphs. I think the important takeaway is you got to design everything for human first, okay? The second one is we actually build purpose-based, and I think that Google Glass is a good example for that. And then, of course, your both is, the voice is the next touch. The voice is the next touch. It's not the touch phone anymore, not touch screen anymore. The final one, which I really don't have time to elaborate, as you well know, if you get mobile world, if you want to do a mobile AR glass, you really don't have too much content you can squeeze to the consumer. So if you really want a mobile world, the content is very, very, had to be poor, very skinny. And therefore, you actually can use video optical see-through. So many glass like Google Glass or Solar Glass can go using optical see-through. But as you get more and more complicated, it is a problem. Like a VR case, you have a VR glass. The VR glass is totally immersive. You cannot see, you don't have situation awareness. The way to do it is using camera. There are a couple of talks today talk about camera. Cameras are beautiful. They can make very good optical image for you. All you have to do is display to you. So I think in the see-through case, see-through allows you to be more mobile. If you use video see-through, even VR glasses can be mobile. A lot of people don't understand that. If you use see-through, video see-through, if you look at the Apple Pokemon is actually a video see-through. A lot of militaries all use video see-through. Nobody uses optical see-through in a very complex data given to you. How about the question in the mixed reality? Well, look, mixed reality is kind of a toss-up, but at the end of the day, I think the video see-through are going to win out because the cameras are beautiful. Camera can present to your eyes in the right format. Your eyes can, your human brain can absorb them because you can massage them with a digital processor. So actually, this is a very important thing which I didn't have time to develop today, the thesis. When you go through the see-through, the optical see-through is okay for information snacking. Once you get more complex data, video see-through is going to win out. With that, thank you very much. I made it in 1 hour. Thank you.